we're going to walk through some things. So we're talking about the central tendencies. So he's talking about the centeredness of data, right? We're looking at what's happening in the middle of the data, right? Because normally when you have a distribution and you want to make some generalization, you want to see what's the performance of one set of data relative to what the average is, right? Or if you're looking at the middle of that data, let's say you can say maybe over 50%, there's less than 50% that because it's kind of a split between the data, okay? And we're thinking, what are some of the ways that we can actually look at this middle value? And there are various ways that we can sort of measure this value, and things like the mean, median, and then the mode, which we'll be talking about very soon. Then again, we have sort of decided we've got the data, we've got the distribution, we look at this, the middle. But then I want to think about what is the performance of this particular data I've collected, or this particular sample relative to what the average is. Yeah. And from that angle, we're just saying there are sort of different ways that we can look at things in terms of how things vary from each other. So we can look at the range, we can look at the variance, and that would take us to the standard deviation. So central tendencies. We've got a range of data. In this case, we've got 11 or 10K, 11K with some repetitions, 11. So it's just data we've collected from different samples. And if we want to find the mean or the average, is summing up all the data and then dividing by what. So basically we've got all the samples that we've collected divided by the total number. So it's the actual data that we've collected. That gives us an idea of the average, or how one performed relative to what the average is, so we can pick up things. But here's the thing. The average can actually be affected significantly, right, by outliers. So what are these outliers? The outliers are the data points with extreme values, okay? So when you talk about skewness, is what varies from the norm. So we've got large sample sitting around here. Then suddenly there is one that says way over there. So if you're looking at real data, you probably have most people getting, let's say 200, let's say 200 to about 205, for example, or 210. Then suddenly someone decides to get 5. So even though we may find the mean, it may not necessarily be exactly in the middle of that data, because there is that huge skew over there. Yeah. All right. So outliers can make the mean a bad measure for central tendencies or common experience, or in terms of what the average experience is. So how do we try to resolve that? We go for the median. So the median, you arrange the data in order. This is where order comes into play. So you arrange the data in order and you look for the middle value. So if it is not odd and you are getting 2 middle values, you just find the average of just those 2 middle values, because then I'll give you the center point. Yeah, so it doesn't necessarily matter like the skewness, because you're looking for the 2 values in the middle, just the 2. Right.
So sorry, excuse me, can you go back? So but does it apply to just 1, 2, 3, 4, 5?
So if you've got 1, 2, 3, 4, 5. Find the middle number of these numbers.
3.
Okay, so if you've got 10, 20, 21, 30, 50.
That's tricky. 21. No.
Good. Okay, how about 2, 2, 4, 4, 6, 7.
4 plus 4 divided by 2.
Are you sure?
Yes.
What's the median?
4 plus 4.
So in response to your question, what's the answer?
So it is.
That's only
Applies to an even set number. Applies to like adding and dividing by 2 applies to an even set number.
Yeah, because then you don't have anything really in the middle. You've got 2 candidates, but those 2 can have a number between them. So if it's the order is, I don't know, and then you've got 6 and 7, it's going to be something 0.5.
Then why did you divide by 4? It's supposed to be divided by 2. No, I think give the final answers for final answers for.
Yeah, I'm just saying there's going to be a division. We flow in, yeah. It's not necessarily, yeah. I know, but
you just wrote the final answer.
as I was doing the division, you said 4. Yeah. He said 4. Who said 4? Was it you or him?
I said.
Yeah, the person that said 4, I just wrote the answer. Yeah. Okay. So the median is unaffected by the outliers because, of course, we're rearranging in order and we are picking the middle number. So it gives us the centeredness. So making it a better measure of centeredness or central tendency. Of course, better describing the typical person. Yeah. So typically a person is right here in the middle, above what the central or the middle value is, below it, or those kind of things. And that was sort of hopefully geared towards stuff questions that you ask us. And of course, what a typical person is, than the mean when the data is skewed. But note that condition there, that's when you have the skewness. Okay, so when you have something like this on there. Okay, so we're talking about what is in the middle. And because we've just written down some numbers, I'm not going to write them again. So it's more about what is in the middle, right? And at the moment, you notice you've got a cluster over there. Where that's it. You've got a cluster over there, right? And I'm all the way here. So actually, if we were to go the average way, yeah, and we're using distance wise, and then we find the average, it's still going to be some tilted that it doesn't really show what the center is.
Okay.
Does that make sense?
Okay.
But think about it with the median, we have to rearrange them in order from minimum to the maximum, and then we are straight away jumping to the center. Then we find in that center value. If we have an even order, even number of orders or even samples, then we just say, okay, even those 2 numbers in the middle, we want to find exactly what's in the middle. So it's helping to resolve that issue of skewness.
Okay.
Yeah. Okay. So if we go to, since she's happy for me to continue now, we go back to how this skewness look and then symmetry. So also earlier, and I just said things about it depends on the data, right? So in terms of what you choose to go for, because sometimes you may be satisfied with the mean. If it is not skewed, if it is symmetrical. So one side is very similar to the other side, then it doesn't even matter. Yeah. So if we say in this particular case, right, in this particular case, you've got this side on the left here. So if I just put a mark there, so you've got this side being very similar to the other side. So it doesn't even matter whether we arrange them in order to find the middle number or whether we do the average. It's still going to end up in the middle number, right? Whilst if, let's say, if we've got we look at if it is skewed, then the mean is likely to give us something closer, right? So coming back, if the recorded values for a variable form a symmetrical distribution, which in this case, let's call it A, the median and mean are identical, right? So in the skew data, the mean lies further towards the skew. So it's just going more towards this particular odd person here. Yeah?
Yeah.
Whilst the median will fall more towards where the actual value is. Because at the end of the day, if you think about it, we go by what we have. If we found the median, the mean, it was probably going to be somewhere here. But the middle number in terms of locational numbers and everything is probably sitting somewhere there. So it doesn't really give a proper representation of the data. So you don't just jump straight in to use the mean. Understanding of the distribution helps. And that is where if the Ghana Jollof area stuff came in, because we're thinking, okay, so is it best to go for mean or not? And the whole conversation. So online, sorry, I know I turned around, but we just think simply saying the decision to go for a particular measuring value depends on the data you are looking at. So you've got A, and then student number B, for example. This one doesn't, and I believe this is what I look like as a stickman with crazy hair. Right. So can I ask you, between students number A and students number B, which one of them is likely to end up with a distinction? The second one.
In terms of middle number, right? Like
which one is likely to have a distinction?
Second one.
Why?
Because there are more A's there.
Because they're having more A's. So normally, if you want to find if let's say all the modules are equally weighted, yeah, you're just simply going to find the average of this, which is adding them together and then dividing by the number there.
Okay.
Yeah. So if you've got, let's say, because it's the same letters, it's easier to see. So if you've got 10 plus 10 plus 10, and these are the values, let's say we scored 10 out of 10. Each time I turn around, if you look away, the question will come back to you, but eventually I will stop. Right? Plus 10. And I say, find the average score this person is getting. What would it be?
10.
The average score is 10. Why is the average?
Sorry.
Yeah. I didn't say the total score. The average. Are you sure?
Oh, the average score is 10. Yeah.
Why?
We confused him.
It's 10.
Yeah, so on average, he got 10. Yeah, right. Okay, so it's sort of easy to say, as far as this person's performance in all the modules that he's taking is concerned, if the maximum he can get is 10, and you say on average he's scoring 10 out of 10, on the average he's getting A, straight away you get the impression that he's a really good student. Yeah, the first one is not very consistent. It's probably likely to end up with a merit, because when you arrange them and you're looking at the middle. So normally people will be under the impression that the average value gives a good representation of what you can conclude about what's in the middle. Because you say, if you go back to my home country, I'm average height.
Average food in the family.
Well, or if you take me and put me in a different country, my height is above average. Does that make sense? So if we look at the score of the majority or the height of the majority, mostly they're around somewhere and I'm above it. Does that make sense? But we're trying to say that's not always the case, because if this student suddenly gets 0, there's a skew. Yeah, there's a skew. We can't necessarily conclude that the average value is there. So you tell me, suddenly it becomes what, divided by 5. What has it changed from 10 to? If we add more of it to it, so let's say we put 2 there, as the numbers go on, we can go further. Then let's say if we have the same thing and we want to see exactly what is in the middle. So for the mean, we got this. But for the median, when we arranged it and what was in the middle is what? 10. Yeah? Yeah, so what information does the mode give us? We've talked about the mean, we've talked about the median, mode.
Highest frequency of numbers.
Which means?
The number that appears the most.
Yeah.
So those things class are saying is the highest frequency of the numbers. And in other words, it means the number that appears the most. So if we look at these numbers, I'm just,
15.
which one?
15K,
Why?
because it appears 3 times.
So even though 11K appears twice, the 15K appears more than the 11K. So the mode is 11, 15. The mode is 15.
21 appears twice and 22 appears twice.
Yeah, but all of them is just twice. Yeah, so good observation. But again, the mode should be the one that appears the most. So we're looking at the data, and at the same time, we're saying that someone has created an anomaly, right? It really makes sense of the actual data. We want to see what is happening in that cluster over there. Yeah? And from what I'm seeing, the cluster actually centers around the manual at the moment because it's like the Tetris, right? And then it says there, I'm glad you can see it as well, yeah. And you and I, the anomalies here, right? So we really want to focus on that side. Whilst in the earlier, the mean was just taking us away from it, right? But with the median, and then of course, the largest frequency number is gearing us more towards the highest frequency number, gearing us more towards what is happening in the center. Okay. So pretty much, well, it may give you the most likely experience rather than the typical or central experience. In symmetric, again, when the data is symmetric, pretty much the same. But when it's skewed, it's completely different. And when it's skewed, you've got a mode going more towards the center, and then the others